非必然。
Pending，
对，
中版。
对。
Pending problem， 来中版。Okay. So the pending problem says that if I put in here with the original angle theta, and I swing it, right? I swing it, right? This is a dynamic problem, right? This is a dynamic problem. So if I ask you, I give you a problem, say, okay, theta, maybe in the beginning, oh, let's say just only 5 degrees, okay? Let's see how we do it, okay? 5 degrees, okay? So you say, okay, that's quite easy because there's a force going on, which is mg, right? Right? So how do you solve this problem? I said, according to Newton's law, right? Again, Newton's law, like the Huntington problem, Newton's law. But now I have to have divided this into this two coordinate, right? So mg equals to this force plus this force, right? Right? 力的分解嘛，分解力。So mg is a force equal to this force and this force, right? And we know because in this equation here, there's a tension that will counter this force, right? So this tension is from this cord, 绳子上的 tension. Tension will take away this force, right? 就是说这两个力量会互相怎么样抵消掉，对不对？所以我们真正对这个来运动的时候，只剩下这个 force， 是不是这样？对吧？是不是这样？所以它只有一个力量，就是这个切线方向的力量。那切线方向的力量是这个力量，对不对？那这角度是不是θ？这个是θ。Right? So according to Newton's law, in this direction, you know, NA, which is again A, right? Or dV over dt, right? Equals what? Equals mg. We say this is mg is here, and this is sine theta, right? Right? So through this equation, you take out this n, and this is like dy. Okay, we'll say it's like a dy squared over dt squared equals g sine theta. Remember? 记不记得？对不对 ？OK。但是这里有错，还是有一个小问题存在。这样子不对，因为这个力量只有在这个地方，对不对？但是我们少了什么东西？我们少了什么东西？对，不是绳子张力，你有一个是应该这样讲哈。Ma equals this force, right? That's one equation. Let me see. Right now you have this T, and then you also have this tension. Let's see. This is mg. 我们少了那个重，应该是这样讲。这边有一个这个，还有一个是重力加速的 mg. mg, you also have this mg. 但是 mg 在这个方向上的时候呢，是什么？就是说这个是 mg， 它是 sin θ没错。但还有一个张力，张力的力量的话，它虽然在这边抵消掉，但是张力呢，它还是有一个想想看 ，what's the problem？ 少了什么东西？少了什么东西？张力应该是说这个方向上是这样跑没有错，但是呢，张力的部分还是有在才对啊。
因为会被要不然它就跑出去，离心力就离心把它拉回来。
对啊，离心力，所以这边的 equation 我做漏了什么东西？我忘掉了什么东西？简单的东西都忘掉了。想想看，哪里 miss 掉什么？miss 掉什么？因为有一个持续的力量，现在在这边传到θ都是这个方向量，然后呢 ，Ma 本身是受它的惯性，所以它受的力一个是这个力，然后另外一个力它互相抵消掉，它力量互相抵消掉。What did I miss? missing something. I missed something. 你看 ，n 等它所受的综合的力。Right? So 1 equals mg sin theta. Then what about this one is here? 啊？
动能的位置。
不是，这里跟动能位置没关系，这是牛顿力学，这里都不需要，当然位置可以另外处理，但是这边漏了什么东西？ I forgot about this. Okay, so sorry. We'll come back to this. Okay, later. I'll give you think about it, and then I'll come back to think about this also. We'll find this fun. So let's not wait for this. 这边有一个小错误，这样的话有一个小错误哈，等一下再说。但是这里的问题就是说，如果给你考试，我为什么会去做出这个题目 ？Why do I want to give this problem? Let's say if theta is 5, this problem is simple because we can linearize this one to be theta. If theta is small, if theta is kind of like small, close to 0, if theta is very small, then you can say this is like A equals dv over dt. You can say something like dv over dt will be equal to g sine. Then sine theta becomes theta, right? And then this is simple problem because your v is related to this only, and this becomes a linear problem, right? Linear problem. And then you can say v is equal to g theta dt, something like that, right? And it becomes simple, right? However, if theta is not linear, is not small, theta is like you 50 degrees, like give you 50 degrees, and this will be different. This becomes a nonlinear problem, okay? So my question is that you need to solve this if this one is big value, okay? It's big number, rather than small number. If it is small number, it's easy. But if it becomes 50, then you have this sine theta. And sine theta cannot be approximated. Sine theta, when it is small, it can be approximated by theta. But when sine theta is big, you cannot do this. And then you become a nonlinear problem. It becomes a nonlinear problem. And so when it is a nonlinear problem, how do you solve it? A numerical method. Right? So I'll give you this problem to think about, okay? And then it may be in my text for your final, okay? It may be in my text for your final. Okay, now we will, because the textbook stops here. The textbook stops here only. But as a matter of fact, this is very, very important, very, very powerful method. I will show you more later, but let's take a 10 minutes break. When we come back, we'll show you how we can apply this to very complicated, like a dynamic or control problems. And we can use this to do a lot of good, important applications, just like MATLAB. And I'll show you. Okay, so let's take a 10 minutes break. We'll come back to show that. Okay?